Hi friends, today we are going to discuss about some important terms in physical pharmaceutics 2 that we are dealing in fourth semester. So these are some terms you can see in different chapters. So important concept we are discussing today. So first is goal number. If you heard about a goal number, that is a term that is relating to a colloid. So goal number means the number of milligrams of protective colloid which is sufficient to prevent the coagulation of a 10 ml standard gold solution. When if we are adding 1 ml of 10% solution of sodium chloride added to the gold solution. So that is the gold number. Okay, so it is a protective colloidal action means it is a protective covering to prevent what? To prevent the coagulation if you are adding a 10 ml standard gold solution when 1 ml of 10% solution of sodium chloride added to it is called goal number. So whatever term is there, you are supposed to write the proper definition according to some standard textbook like Martin, or you can use C.V. Subramaniam like that. Okay, so whatever it is, if it is a term, if any option is there to include one diagram or example, it's better to improve your mark. So for the goal number, you can tell like this as example for gelatin, the goal number is from 0.005 to 0.01, or if it is albumin, it is zero point 0.1. If it is acacia, it will 0.1 to 0.2. So whichever convenient to you, we can add one example. So next one, bulges and spur. So it is a term have to be there in your mind. So bulges and spur. This two you can see in the chapter rheology. So first of all, we are telling about the bulges. Bulges means if you want to tell, you have to explain with an example. So if you are taking aqueous bentonite gel, if it is in the concentration 10 to 50 percentage by weight, it will force or it will result in some hysteresis loop. Okay, so in the up curve, you can see some loop. The mechanism is that you are just assume if your mechanism, the bentonite, we are telling the crystalline plate of bentonite, it will form a house of card. If you keep the card above the other like a card, and it will cause the swelling of the magma or our aqueous bentonite gel. So this 3D structure resulted in the bulge loop. So we are expressing like this. So if it is a rheogram, this is a rheogram. So you have to suppose to draw F shearing stress on the x-axis, and you have to plot the rate of shear G on the y-axis. So this is like this. If you are keeping the rate of shear like this, at the end due to the bulging of the card, it will show like a bulge. So you are supposed to draw what? The direction. So it is bulging. Okay, so this is the direction of bulges. At the same time, if it is a spur, same thing, you are supposed to draw the rheogram. You are supposed to draw F on the x-axis and rate of shear here. Instead of this, it will show a, instead of this bulging, it will show a protrusion like this, and we are getting one sharpened point. We are calling it a spur value Y. So let me protrusion, spur like protrusion, and this will happen due to the structural breakdown, and it will result in the Y value, and we are calling that spur value as Y in the up curve. So that spur value represents a sharp point of the structural breakdown and a lower shear in the up curve. So this is what spur. Next one, shape factor. So this is a term you can see in the chapter micromeritics. Okay, so it is a term relating to the surface area to the volume of the particle. So we can tell like that. Shape factor, it is a ratio. Okay, shape factor is a ratio of surface area factor, that will be alpha s to the volume of the particle. So shape factor is equal to alpha s by alpha v. Normally we are getting a value of 6. Okay, so that is a minimum possible value for the shape factor 6. So if you are getting a value of shape factor 6, it represents that particle shape should be a spherical shape. Okay, sometimes this value will greater than 6 or exceed 6. So at that time the particle is considered as a asymmetric. Okay, so next we are going to discuss about another term, zeta potential as well as nurse potential. So zeta potential, they're asking what is zeta potential? Give an example. So zeta potential means if we are keeping a two particle in the dispersion medium. So what happens is that at the two end of the thing, it will create a potential difference. Okay, so zeta potential means the potential difference between the dispersion medium and the stationary fluid. That is means by zeta potential, and this zeta potential or difference can be seen at the shear plane. Whereas nernst potential are the name is electrothermodynamic potential. So it is the difference in the potential between the axial surface and electroneutral region. So they are telling to add an example. So if you are adding a lecithin, what happens is that it will stabilize the triglyceride in the thing. So if you are adding a stabilizing agent, it will adsorb on the surface and it will consequently avoid the electrostatic action. Next question is about what is the difference between bulk density and true density. So bulk density can be represented as rho. So bulk density is equal to whatever density mass by volume. So mass of the powder, instead of that volume we are calling it as bulk volume. So bulk density depend on the particle distribution, shape and cohesiveness of the particle. Okay, that is what bulk density. Whereas true density means it will depend on the type of the atom, arrangement and arrangement of the molecule in the sample itself. So various methods are there for to find the true density, like gas displacement, liquid displacement method, etc. So you are supposed to write draw the bulk density as well as trap density, and C represent granular density and true density. So hope you know what is the difference, right? In bulk density it is properly distributed, whereas in true density what happen is that we want to think about the arrangement of the atom. Next question is about differentiate between microemulsion and multiple emulsion. Micro means it should be the globule size emulsion, right? So we are telling about the globule. The globule size is about 0.01 micrometer, and this droplet cannot refract the light. So this droplet cannot be visible through the naked eye. So what happens is that this microemulsion will act as a transparent system, and as well as it is a thermodynamically unstable system, and comparing to other emulsion, microemulsion having enhanced bioavailability, example etoposide, methotrexate, etc. Whereas multiple emulsion means multiple. Okay, so emulsion within emulsion, so let it be water in oil in water emulsion. So what happens is that how we are preparing is a water in oil emulsion. If you are dispersing in aqueous phase, we will get multiple emulsion, water in oil in water emulsion. So what happens is that if it is a multiple emulsion, the drug incorporated in the most layer must uh, adsorb. It will go through the boundaries, and normally this multiple emulsion we are using in the preparation of sustained release, especially oral sustained release, as well as we are using it intramuscular. Next question, what is the difference between ferrite diameter and projected diameter? So if you want to measure the particle, so we are supposed to do different type of diameter. So let it be projected area diameter, Martin diameter, ferrite diameter, like that. So our question is about ferrite diameter as well as projected diameter. So ferrite diameter means it is the distance between two tangents on the opposite sides of the particle parallel to the some fixed duration, whereas projected diameter we are representing by dp. So it is the diameter of the circle with the same area as that of the particle observed to the surface on which particle rests. Okay, so ferrite is the distance between two tangents, where projected means it is the diameter of the circle the same which the particle observed to the particle test. Next question is about what is kraft point. Kraft point means it is a temperature. Okay, so it is a temperature at which solubility of the surfactant is equal to CMC. So what happened at that when the temperature at which solubility of surfactant become equal to CMC, the concentration of surfactant will be such that to form a micelle or micelle. So what happened? If it formed the micellar like that, the solubility is increasing several form. Normally, this behavior or this type of pack, mainly this temperature difference is shown by the non-ionic surface active agent. And by considering this thing, what we are doing, normally we are preparing all the colloid above this Kraft point KT. Okay, so these are the some important concept in physical pharmaceutics too. Hope this will be useful. If you find useful, please play share to your friends. Thank you for watching.